Hi, I am Peter, and I will be guiding you through this module on different mathematical tools regularly used in financial analysis. In this video, I want to focus on the steps necessary to calculate covariance and correlation when evaluating probabilistic scenarios. We will continue working step by step. Let's get started. We will perform the calculation step by step using Excel. The first step is to calculate the expected return separately for each firm, TTI, and GEC. This expected return is the result of adding the estimated returns for each scenario, weighted, or in other words, multiplied by their respective probabilities of occurring. We can also interpret this as the expected return for each of these firms, looking forward, considering the possible scenarios we may encounter. After calculating them, these expected returns are 2.15% for TTI and 1.55% for GEC. Once you have the expected return for both firms, TTI and GEC, you can now calculate the variance and the standard deviation of their returns. Remember that we performed these calculations step by step in one of the previous videos, where we covered standard deviation for probability scenarios. Just to refresh your memory, we need to calculate the deviation of the return for each of the scenarios from the expected return. These deviations must then each be squared and multiplied by their respective probabilities. Finally, remember that the sum of these squared deviations multiplied by their probability is the variance, and the square root of the variance is the standard deviation. The third step to calculate the covariance is to multiply, for each month, the deviation from the expected return of one firm by the deviation from the expected return of the other firm. In this case of probabilistic scenarios, we also multiply by the probability of each scenario. So, we are multiplying three terms. First, in cell H3, we multiply the deviation of TTI, which is minus 0.0715, by the deviation of GEC, which is 0.0645. In this step, we are multiplying the deviations without squaring them. That is, the values from column E with the values from column G. This will give us the interaction of the deviations of TTI and GEC. Then we must also multiply each interaction by the probability. For example, if you multiply cell E3 with cell G3 and with cell B3, you will get the value shown in cell I3. In the first video on covariance and correlation, where we worked with historical data instead of scenarios and probabilities, I go a bit deeper into the interpretation and meaning of covariance. If you haven't yet, make sure to check out that material. In the video where we calculated covariance by evaluating historical data, the last step was to average the interaction values. In our case, by weighting or multiplying each interaction by its probability, we have already done part of this averaging exercise. Therefore, we only need to sum the values in column I. By summing these values, we get a negative value of 0.00225. This indicates that generally TTI and GEC move in opposite directions. However, covariance is a bit difficult to interpret, which is why we will standardize it, or in other words, convert it into a parameter that we can more easily understand. To better interpret the magnitude in which the movement between TTI and GEC or any other pair of firms is positive or negative, we finally standardize the covariance by dividing it by the product of the standard deviations of both firms. First, we multiply the two standard deviations, 4.88% and 5.24%. The result we get is 0.002557, and this will be the divisor. We then divide the covariance, which is minus 0.00225, by the product of the standard deviations, which is 0.002557, and the result is negative 0.88. Remember, no matter which series of returns you evaluate, the correlation will always have a value between -1 and +1. In the previous video, I also go deeper into the interpretation of correlation. Thank you for your attention and for the great work you've been doing. Let's stay in touch.